In today's episode, we asked the question, can you make your own three-phase thermal battery inside your house? Well, the answer is...
yes.
Remember, you got to say it with more gusto.
Yes.
Hey, I've been called in to this job because at the minute they've got tons of solar panels and all that energy is being sent back to the grid. And do you know what? We're being ripped off for electricity at the minute. So we want to see if we can use all of that power here on site. Let's get into it. I'm here with Ollie.
Hi.
And Ted. And Hector. Oh, you're my favourite one. Yes, you are. This is the plant room that we're working in. So it looks a bit complicated. And that's because for a house, it is very complicated. It's a double boiler system. So you've got these two boilers, you've got a low loss header here. Is that the only set of underfloor heating manifolds? I'm pretty sure there's another one somewhere, but you've got heating manifolds. But this here, this lovely big tank, this is gonna be our thermal battery. When I say thermal battery, that means battery to store energy in, I guess, it's thermal form? I don't know, I'm not a scientist, don't claim to be. So I'm gonna use eddies. I'm gonna be using these, except I'm gonna be using them to their absolute max. The thing that makes this a little bit more complicated, right? This is a three-phase immersion heater. These eddies are designed for single phase. So my hope is, and my theory and my plan is, if I get 3 of them, which I have, and put 1 on each phase, if I can get them to talk to each other, that will be lovely. So Ted, what do you make of this plant room?
It's really neat. They've got really neat labels here. They've even got the little logos for each of the circuits.
That's Oliver's wife Eden that's done that. You can't, if Ollie tries to take credit for that, don't let him. Ted, I'll explain it to you, right? You've got this pump here. This is the underfloor heating pump, okay?
Yeah.
And each one of these, this is the manifold, this rail, with all the pipes going out, and each one of these is an actuator. So an actuator basically is a voltage operated switch. It actuates on a voltage signal. When it gets that signal, it'll either open or close, depending on what it's programmed for. They go up to this system here, which this looks really, really complicated, but actually once it's broken down to you, it's really not. Inside there, you have your actuators. That little rail there means that all these ones are all linked out. So this is effectively one cable. What that does is that goes over in that multi-core ØY cable.
Yeah.
Up, along, down, and into these heat miser units. A bit complicated. I'll explain it to you better, Ted, off camera. But for the purpose of the video, I'm just explaining to where stuff goes. I'm going to come out of those spares, up inside the trunking, along, down this tube here, which goes round to there. This was run in for a PT100 sensor in there, but we didn't end up using that one. So now that's spare, I'm going to put some brackets on the floor, have a stand, have the 3 eddies mounted on those brackets. We've also got to bear in mind, to switch that kind of load, you need contactors. Step 1, let's get the unistrut cut, get all of that in here. And when we start wiring, we can start explaining all of that to you. So I need to build this unistrut frame, but I don't really have a plan for it. If I open up the eddy and take the fixing brackets off, I'm hoping then I can try and budge something together. So what this does is this varies the current. As far as I'm aware, it's the only solar diverter that will actually vary the sine wave of power. Is it? Yeah, the vary sine technology. So it will vary how much you've got. So other solar diverters, like I could probably bodge together a solar diverter myself, or if the geeks that follow this channel probably could do that with a Raspberry Pi or something. The level that this does it to is absolutely fantastic. It's not just a switch, so it will vary exactly how much you've got. So say you've got 1.7 kilowatts spare going back to the grid, then it will send exactly that amount spare going back to the grid, and the other stuff, it will divert around the rest of the house. And because we've already got zappies, we've already got other things, we're going to be having the new My Energy battery out the back as soon as it releases. It just means that on one app, you can monitor everything. I have my back plate. Oh, that is a match made in heaven. Look. Exactly perfect, that. Just thinking how we can make it a bit stronger. So I'm not worried about it falling that way, I'm more worried about someone pushing it. Maybe we could get some 10mm threaded rod and brace it off the wall or something. Let's go build it outside, and then we can bring it in, stick it to the floor. Ollie's on with all the smart stuff while I'm doing all the donkey stuff. all the devices, they would talk to each other wirelessly, but we've got a bit of a complicated setup inside this house. So there's everything, isn't there? There's like Control 4, Lutron, like the Homeworks, obviously the My Energy network. So we've got it all on that LAN, and he's just connecting it now. So all the new My Energy stuff, it's got the ability to do that. It's got the Ethernet port inside of it. So Ollie here is just putting on these RJ45 cables. The actual main incomer is over there. Let me show you. So you've got this big old switch fuse here, and then the CTs are attached on just there, and then they go back via this data cable through there. So that then goes back there through to master Zappy, which is Zappy 1, the Zappy on the right. So that then will monitor the power basically, and so that will know when there's excess and when it's sending it back to the grid. Because we have the CTs on the incomer, we'll have another CT on the solar circuit, which is also a 3-phase circuit. And then the My Energy system will know when there's excess being sent back to the grid. And then we'll prioritize it. So we'll say, okay, when you've got this much power, charge the car. If you're sending power back to the grid, don't send it back to the grid, because what's the point in generating it, selling it to the grid, and then buying it back for a more expensive price later? It doesn't make any sense. So if you want to be a prosumer, say, okay, charge my car. Once my car is charged, charge my battery. If I've still got that, charge my thermal battery, heat up the hot water system. So that's basically what that will do. Bolt, don't think it really needs a washer, and I don't want to pack it out anymore because I'm worried it will hit the device and conflict with it. Then I'm going to go square washer and Zebedee, or some people call them channel nuts. I know Americans call them channel nuts, but yeah, that will just go inside the Unistrut channel and hold itself tight. Happy with the height of that one. Get that tightened down. 200 off the floor. That's 200. We'll probably have to square it all up once it's in. There, that is a bright light. Got the Unilight set up there. Oof, big old spot growing out the side of my face there. So we are inside the plant room now. So this is all done. Let me show you. So it's such a tight space to be working and filming in. But we've got Ollie here prepping all the singles. So those singles are going to be coming out of that board, up inside the trunking, along, down that conduit and into our little control board. So we've put that threaded rod across. It looks like it's bent, but it's not. It's really annoying here. It's because of the tank being round and the shadow. It's a bit of an optical illusion, but that is straight as an arrow. And then that's fixed to the floor, ready for the eddies and the control box on the top. You happy, Ollie?
Yes.
Remember, you got to say it with more gusto.
Yes.
Ollie and Ted are just on with the other bits at the minute. Obviously this is all mounted and now the cables are pulled through, so we're going to come out of that with some flexi. But Ollie here is just putting them away into the board, making it look absolutely lovely. See there? Wow, that's so pretty. Look at that. It's the details that you will never see as a customer, but Ollie has learned from me to do. This is probably not such an entertaining one, really. More of an educational and geeky one, which is okay.
I could try and make it more entertaining for you.
Yeah, go on, make it more entertaining.
Where's the...
There you go. What's your best joke? I've got tons of jokes. I'm thinking of leaving electrics though, you know. I'm thinking of giving up electrics completely. Because I'm thinking of working in a mirror factory. I feel like that's just something I could see myself doing.
A mirror factory? Or just constantly see your reflection all day?
I could really see myself working in a mirror factory.
Oh, good one. Just chuck in there.
I'll just chuck it in, yeah. Just chuck it in. Who taught you? Heck. I think you've been working with artisan or something. Just chuck it in. We don't work like that here. Not with ØY08 chili.
Did you hear about the new restaurant in the room? Great service, no atmosphere.
Did you hear about the blind circumciser?
No.
Oh, he wasn't very good. He got the sack. What do hamsters and cigarettes have in common? Both of them are completely harmless until you put them in your mouth and set fire to them. Oh, that one got Ali. It made him start having a coughing fit. Seen Hot Rod?
That movie?
Yeah.
Never seen it.
You've never seen it? Have you ever seen Anchorman?
Which one?
Both.
I think I've only seen the newer one.
How can you only have seen the newer Anchorman?
Anchorman?
That is deadly, don't do that. It's going to flick a broken bit of Braden's mind. Just a little screwdriver inside that hole. You can't watch the second one without having watched the first one.
Well, I have.
Well, you shouldn't have. Do your parents know? That is installed. Okay, so now we have the cable coming in through there, up into our box, just here. You can see there where I changed my mind mid-drill. But yeah, that's coming into our contactors, ready to go. Okay, so the cable is coming from the board through this, and you've got one here for temperature control, so you've got a thermal cutout, and one for overload. Typically, it would just go straight into here, out of there, into there, out of there, into the immersion heater. However, we want it to go via the eddies, so we've just been racking our way of brains of a smart way of doing it. I think what we're going to do is we're going to flexicon out of the back of here into each one, have the feed in line neutral, neutrals come and bust out so it doesn't matter, and then a feed back the load out of the eddy, because the thing is, we don't want, if there's a temperature issue or anything like that, we don't want the eddies to have the power cut to them. So the power out will then go into the load, which is this, through these two contactors, and the A1 and the A2 of these two contactors is switched by these thermal cutouts. Don't get confused by that. I explained it to Ted earlier. I said the way a contactor works in science principles, it's a magnetic coil that will open and close a set of contacts, right? I said, imagine, I said, I want you to lift that box over there, but it's too heavy, you can't lift it. Well, it's like you tapping them on the shoulder and saying, excuse me, can you go and lift that box for me over there, please? It's too heavy for me to lift on my own. That's effectively what this is saying. These little contacts here, that's what you need to say, yeah, power's not safe now, we need to cut the power, but that's not man enough, or woman enough, to break the power going through this. You couldn't put the power for this immersion heater through there. So instead, we run it through a contactor. This will send an electrical signal to here, the A1 plus A2, the A1 and the A2, sorry. And if it's normally closed, then the electrical signal will trigger the electromagnetic coil to open. And if it's normally open, it will go close. So that's what they're doing basically. There we go, that's all the eddies mounted. That beautiful masterpiece. We're going to be coming out of the bottom here, up, and then that is going to tuck in as very nicely presented by Ollie. So that's our three eddies. Ed, and Eddie. I'm getting an immense amount of satisfaction out of this, I don't know about you. You don't look very satisfied.
No, I am, I'm just...
Look, you want to go home. This is probably going to be the worst cinematography the world has ever seen. Am I even in frame? Do you want to check? So I'm relatively confident that I'm not. No. Yeah, go on, move. Yeah, go on. Yeah. You go on, have a cheeky little move down in that frame. All right, let's go sketchy. Time to do some sketchy stuff. Doo-da, doo-da. It's so late. I think, guys, if it's time for bed, don't stay up and watch this. All right, it's night time. Just go to bed. Good night to everybody except Asians.
No, don't laugh. It's not because it's racist. Because there's a time difference.
Oh,
they're just waking up.
Of course.
Good morning, Asians. I love you too. I got your back. Quarter Asian. Right. That's the last one done. And I'd say it's quite beautiful. Cool. Look at the Copex on that one. Oh, you don't do that. You can make people motion sick. You just me zooming in and out. You should have seen my footage in Norway. It was so bad. That video. It only looked half all right because the editor like salvaged it. He was like, what were you doing? Like, how was it even possible to look that bad? I was like, I don't know.
Okay.
Yeah, looks good to me. I like how Ollie provides us really filthy conduit. Thanks, chili. I'm not even going to call them chili. They're not worthy of it. I'm going to call them peppery. Mildly tingly on my tongue. Electrical. Moderately spicy. The madras of the electrical world. Your mum's definitely not going to let you work with me after she sees this. Like, that boy is a complete and utter moron. And I don't want you associating with him. Okay, that is us done for the night. It is now 7 o'clock and it's a Friday and it's been a long old week. So if you've seen the rewire video by now, that was only yesterday. So yesterday I finished at like 11 o'clock at night. So I'm a little bit tired today. And I'm also working early tomorrow. Just trying to catch up. Once I'm caught up, I'm saying no to more things. At the minute, we've got the stand mounted. It's looking lovely. Got it all clean. Got these contactors in. Let me show you. So they're looking good. So we'll have the thermal overload one, thermal cutout, and the overload one. See, it's just a normal contactor. So the way it's going to work, right, is you see these immersion elements in here. These will control the A1 plus A2. So you've got your thermal one, so that will be my A1 and A2 going out, and this is my overload one, so that'll be my A1 and A2 going out. So we've got the feed coming in from the board. Each feed is going to go down to its corresponding eddy and back up again, and through the contactors, out through there. Hope that makes sense, and I will see you lovely people on Monday. Well, hey, we're back. It's a new day. It's now Monday morning. We've had a very, very busy weekend. It wasn't really much for rest. Ollie is just on with doing the LAN, which I'm going to explain to you how he's done that. We've got a lovely little drawing to explain it. What we've got is all the individual connections are made via Cat6. The link between outside and that router and the switch and the router, both those switches, they're both made in fibre. So Ollie is doing all of that. We've got these little labels, heat shrink ones, to differentiate in and out. Put those on just to make it a bit clearer what's doing what. So that's power in on that one, out on that one. If you're wondering why I'm not ferruling these, the reason is because it's a solid strand. Oh, it's a flex cable, but it's a solid strand flex. And on certain terminals I would. If it was a terminal with a sharp screw where I'm protecting the flex, then I'd do it by all means. But when it's a clamp terminal, I very much disagree that it's something you have to do. And people can fight me on it until the cows come home. But at the end of the day, that's what I've decided is best. These are properly soft stranded cables on this HO7 rubbery flex. That's what a soft stranded cable looks like, and that has been ferruled appropriately. I feel like there's a craze at the minute where people have just discovered ferrules and are just sticking them on absolutely everything. I saw ferrules on Twin and Earth the other day, which is shocking. But it's like, they see it on Instagram, they think, oh yeah, I have to ferrule everything. And they don't ask the questions why. People go so far as calling you out. I had someone call me out on a past video for not using ferrules on a Twin and Earth cable. I was like, step one in life, don't argue with an idiot. I sent them a reg. It says about appropriately terminating the end of conductors and something about them being liable to damage. Twin and Earth, putting a ferrule on the end of that is making it a far worse connection, because actually you can just guaranteed tighten it up in a ferrule. You'll be able to pull it straight out.
Okay, so we're all finished with the wiring. Now we're just trying to do the network setup, but it's proven very complicated because we're not just doing a wireless protocol, which is what you usually do on a system like this. We're mixing, so we've got some of them are wired over the LAN and some of them are still talking wirelessly. So for example, it's a wired connection out to the Zappy outside, where it's got a wired connection to the CT. But then inside here we have a Harvey connected up to one of the eddies, which we're setting as a master. The Harvey, what that does is, I'll show you, basically clamps on CTs like that, and that we've got one on each phase of the solar, and then that lets the device know when there's excess power, and then that enables it to be used as a thermal battery. But at the minute we've just got this switch here, network switch, temporarily connected up, and we're just trying to figure it out. So once we're finished head scratching and actually finished it out, I'll be able to give you all an update.
Right, so let me explain the wiring then. So we've got the thermal cutout and the overstat. Your neutral's all commoned up, and then you see that one there with the linking bar across it. That's L1, so that's linked out, and what that does is that goes down all the way to here. It links out the commons, so these are the power in basically to these stats, and then it comes back up those switch lines and switches these contactors here. So you've got one switch in there, one switch in there. And I'll show you what it looks like when it engages. If I turn the temperature down, right, you'll hear it click. And then back on, reset. So let me show you that up here, right? See what happens as that contactor kicks out. See that?
FYI, we sorted out so that they operate in series. So we use the spare normally, we use an aux contact.
Yeah.
So that when that's energized, then the thermostat is enabled.
Cool.
Can you pull a couple of meters through just before you film again?
While we're doing that, we're just pulling through this Cat5. This is going to be for the CTs. So basically we reached our max device limit on the CTs. The Harvey was the thing that broke, the straw that broke the camel's back. Basically there was just too many devices on there. The My Energy ecosystem, you can only have 7 devices, 6 devices, and the Harvey was the 7th device, so I happened to put in a Cat5 cable, which we're going to split up and do the different CTs on.
If we can get that to there, yeah.
What, this Cat5 through that flexi duct?
What we could do, I could daisy chain them and just take out the pair that we need in each eddy.
Yeah, good idea, just straight through. So what course are you doing, Ted, at college?
At the moment I'm doing a level 2 diploma in electrical installations.
Is that 2365?
I think so, yeah. That's with City and Guilds. That's going to take me a year, and then afterwards...
One minute. There you go for it, sorry.
Afterwards I'm going to be doing the level 3 course, still from City and Guilds, and that's also a year, so it's in total 2 years, and then I'm qualified.
To do your apprenticeship?
Yeah.
You're half qualified. That'll be your knowledge units, then you need your MBQ. But that's the hard bit, then the fun bit is the actual MBQ. Yeah. And also, if you work with me now, you could actually start filling out your MBQ now, so you could technically be qualified by the end of it. Okay, there we go. We've got the data cable through, so that's running back to over here, where he is just heat shrinking and connecting those on. So that's going to connect on to all the different eddies. And then I think what we're going to do is daisy chain that CT cable through. Right, so that CT cable has gone through, and Ollie has been doing a beautiful job terminating them all. So the cable just loops through and up to the end there. So we've got a CT per pair basically, and that's going into the CT terminal. And then that is the CTs all done. Gonna give us a thumbs up?
Yeah.
Ah, that's more like it. Guys, I think we've done it. I think we've made a 3-phase thermal battery. That was a bit of a mission, wasn't it? Goodness me. You didn't see the worst of it, but there was so much head scratching getting the connection sorted because it's over such a huge distance. But I didn't realise how much information I could get off of this. I'm just going to show you very quickly for the internet geeks out here, because you see, I can't show you the serial numbers, but I don't know that much about networking, so I'm still figuring a lot of stuff out as I go. I'd love to learn more, but I'm learning slowly. There you go. So I have seen, basically, it will share the packets of information across the radio and the Ethernet. So if you see there, it's still transmitting radio, which is shocking. I was not expecting that because it's miles away. Well, okay, it's not miles away. It's a good distance away. I'm going to do a quick walk round so you can see how many devices are connected, but we've got on this site something like 11 MyEnergy devices, but you can only have 6 per network. But fortunately there's 2 supplies. So there's 6 now on this supply, which has maxed this supply out, and then there's a few on the other supply as well, 4 if my maths are correct. So there's a lot of zappies for one house, but the guy who owns the house is a legend. He's properly future-proofed everything. He's really into trying to make everything smart, efficient and green, like me. That was horrendously cringe. I really hope that's cut. That's it. I'll show you the finished product. I'll try and get some B-roll. I haven't got a lovely cameraman with me today. Stu was just off getting his hair conditioned, so you're just forced with me basically. But that's why it's so sketch today. Well, yeah, today and Friday. It takes a few days to condition his hair. It's most of the weekend really. But yeah, this is it. This is the finished product. And these are my socks. I think they were off Amazon or maybe from Primark. You know, I'll try and chuck a link. But yeah, I'm pretty happy with it. So, Ollie's left his shoes here. Do you want to go see if he's left? Just quickly give him his shoes. I'll leave them there for him. He'll be coming back. I'll leave him with his boat level there. Let me get some nice B-roll shots, Ted. Here, go on, pretend we know what B-roll is. Do you want to just stop calling me? Do you want to just stand next to it and make it look like you know what you're doing? What's your best B-roll pose you got? That's an A-roll pose, that, mate. This is a crime. We can't make this B-roll. Go on. Best B-roll face. Perfect. So now that right there is a beautiful big 500 litre thermal battery. So that is a thermal store of our excess solar energy. So solar energy comes in, and then rather than just back to the grid, giving it straight to the Russians, the mean Russians, not the nice ones. I like nice Russians, just not the ones that are doing naughty stuff right now. That then goes through these eddies, and eddy per phase heats up those elements and heats up that, rather than just sending it back to the grid. Grid, so greedy. Stop having all of your solar energy. Start using it. Make thermal batteries, get lithium batteries, whatever. If you've got renewable energy, stop sending it back to the grid. Right, let me show you around site. So we have Zappy 1, Zappy 2, Zappy 3, Zappy 4, hiding behind there. And that's just on this property. But there is 2 supplies to this property. You've got 1 to 1/2. Then also up on that roof there, that is where the solar array is, which is, I think, 12 kilowatt. It's like 4 kilowatt, 3-phase solar edge system. So that's perfect. So now all of their excess energy is being captured by the MyEnergy network, which is exactly what we set out to do. So I think that's pretty perfect. If you want any of the tools from today's video, then head over to Tool Monster, use my code in the description below, and you'll get 5% off of everything on their site, including all my merch. A massive thank you to, I'm getting funny looks from the builders. I'm gonna finish in a sec. There you go, do you see that? So these little exclamation marks basically mean that it's not updating the information fast enough, but that's because the Ethernet is down at the minute while Ollie is finishing up on that last little bit. But that's all done, so you can go into different settings, you can track all the excess solar where it's going. So when these are all set up, rather than any of it go back to the grid, it will just go to all your different devices. So that is everything. So a massive thank you to Ollie, this guy. If you want to see more of Ollie, go check out Chile Electrical, where there is some stellar work, and also he actually understands networking. I might be able to crimp cable and know how to terminate cat cables. That does not make me a networking guy. This guy is. So go check out his page and his Instagram as well. All the links to that are below. Massive thanks to everyone, and
If you're interested in more of this type of content, don't forget to like and subscribe, and I'll see you on the next one. Thanks.